Hi there, and welcome to another episode of the Degenerate Era Podcast. And this is a pretty cool one. This is one that I wanted to do yesterday, and I never got around to. But as the title says, for the first time ever, an image of a black hole has been captured and released. Every other image of a black hole prior to this was always just a computer graphic, a sort of visual representation of what our understanding was. But now there's actually that image, and this is really massive news. Going forward, we're going to be able to figure out a lot more to do with black holes, their effect on space-time, the mechanics of them, how they work, how they operate within space and time. So this is really cool. So before we jump into the new image and have a wee look at what that's all about, let's just have a quick rundown on what a black hole is. So a black hole is basically a region of space from which nothing, not even light, can escape. Now, a black hole is made up of a few different regions, and these are what then come together to be that black hole and act in the way they do. So the parts of the black hole, in the very centre, you've got what they call a singularity, and this is a infinitely small, infinitely dense point in space and time with a massive gravitational pull, and around the singularity you've got the event horizon, which is the gravitational boundary, and once you go past that or inside that towards the singularity, the gravitational pull becomes so strong that nothing can come out. Around that you've got the accretion disk, which is basically the swirling mass of matter, which is being caught in the gravitational pull, and it's now orbiting around it, being pulled in towards that singularity. And also we may see the relativistic jets, which is the matter and radiation extending out hundreds of thousands of light years, with that radiation being spewed out of the black hole region, and that has also been captured in an image as well. Now, one thing you certainly would not want to do is fall into the black hole. If a human was to fall into a black hole past that event horizon, we would be intact as we made that initial step of the journey. But as we got closer and closer and further into the black hole, further past the event horizon towards that singularity in the centre, the gravitational pull would be so much stronger, even say at your feet compared to your head. If you fell in feet first, that the gravitational effects on your feet would be so strong, even compared to your head, that the black hole would begin to pull the very fabric of your being, the matter and the atoms that construct a human, that those would be pulled apart bit by bit, and as your feet got further in, that would begin to be pulled further away in something called spaghettification. That would be the name of the process, is spaghettification. We would literally be pulled out like strands of spaghetti as the black hole pulled us apart, or the gravity of the black hole pulled us apart. So you don't want to do that. So anyway, that's the black hole. So we're going to just jump in now and have a look at the first ever image of the black hole and what this image actually shows us. So this image here is the black hole at the centre of the M87 galaxy, which is about 55 million light years away. The black hole's about 40 billion kilometres across, which is 3 million times that of Earth, which means that the black hole's actually larger than our whole solar system. And the black hole that we've got a picture of now has a solar mass of about 6.5 billion of our sun. So this thing is absolutely massive, and it's believed to actually be one of the biggest black holes out there. Although it is good to note that, this black hole was caught in a tiny little patch of sky. It is a big sky up there. There could be far more like this, or could be even far bigger, but to the best of our knowledge, this is one of, if not the biggest that we've ever seen. They called it a monster black hole. So this was put together by a team of scientists, about 200 of them, working on the Event Horizon Telescope project. And this is a project with 8 different satellites that are situated across the planet, and they were all focusing on that one area, and they were actually focusing right on this very specific black hole. They were looking for it, focusing on that galaxy. And because they had all 8 focused on the one area, they were able to use the individual power of those telescopes and the technology we've got within them, and they compiled all that data together, and then they were able to get this image out, which is really, really cool. So, sorry. So, as we're looking at the image from the Event Horizon Telescope, what it can tell us is that the gravity bends the light from the accretion disk around the black hole, the Event Horizon, giving it the appearance of that halo. And it would look like that from no matter what angle. It would all depend on the gravity and the way it's affecting the light and the matter being bent around that. But that little glow on the image is the actual evidence for the Event Horizon. And the cool thing about this also is that the measurements of this not only align and match up with our simulations, but also they're consistent with Einstein's predictions as well. The lighter areas on this image indicate that the radiation from the gas and dust and matter is moving towards us. That's why it appears brighter. And then on the flip side, radiation from the particles that are moving away from us in the opposite direction appears dimmer. So moving forward, there's a few things that this breakthrough is going to be able to help with. For a start, with it being with the new image and the data being consistent with Einstein's general relativity, the hope is that we're going to be able to observe event horizons in the future with higher resolution eventually, and it will help us to figure out how the quantum mechanics and the relativity mesh together, because it is such an extreme area of space. Literally 2 days ago, we knew less than we do now, and we still don't know it all. Obviously, there's a lot more to figure out. One of those things being Hawking radiation, Stephen Hawking's theory that the radiation of the black holes evaporated away on the edge of the event horizon, which through time would, as we're talking like ridiculous number of years in the future, like eons ahead in the universe's age, where matter begins to decay, fall apart and die off, and you end up with that kind of heat death entropy of the universe. The Hawking radiation, that was part of the theory was that this existed, and this has not been observed yet. This image does not mean we've officially observed the Hawking radiation, so for now that's still theoretical. But moving forward, we never know. This is a step in the right direction, and we might figure more out about that as we go forward. Another thing that we're not quite sure about is whether it's actually the accretion disk, the black hole, or both that are rotating. So these are things that we're going to be able to look at with more precision and really hone the understanding and sharpen our understanding of what's going on there. So exciting times going ahead. Don't really have much more to say on any of that. It's not like I'm a scientist. I'm literally just finding stuff out from sitting on the internet and reading and watching and trying to learn and understand. So this is pretty cool. The black hole phenomenon is one of those things that kind of think about, read about, don't really know much about it. We know a lot more than we did, but we still don't know all that. So it's cool. And they're one of these things as well that just they've been kind of glamorized and in Hollywood and such. You look at movies like Interstellar and whatever, and I think this kind of phenomena is one of those things that really get the imagination going. So this is exciting moving forward. Another thing note also is that they actually the scientists at the I forgot the name of it now. The scientists at the the Event Horizon Telescope project, they actually also looked at the black hole at the centre of our own galaxy, and as far as I believe, there's no images of that, but it's actually meant to be a lot harder to get any images of our own galaxy's black hole at the centre, even though it's obviously a lot closer. So there's probably going to be more information being leaked out or released in the coming months and such regarding that as well. Although compared to the monster, the unseeable monster that we can see now, it's believed that the one at the centre of our own galaxy is far smaller. So yeah, just suppose we're going to have to sit about and wait and see what happens. But yeah, I think that's about it for now. Just wanted to quickly get that out there. Like I said, I wanted this up yesterday. Today I'll have to do better late than never. Anyway, that's all for now. Coffee time. Peace.